Right, this is the second part of the lecture 12, and in this example, I'm going to, in this case study, I'm going to look at a document analyzer. In fact, I'm going to look at three slightly different things. The first one is I'm going to read in from a document, any standard text document, and I'm going to generate a list of unique words from that document in alphabetical order. So this is something you might want to do to analyse what sort of words you've got in the document, or if you were searching for a particular word in the document. The second thing is something very similar, still with one text file, read in all the words and generate a frequency analysis. So not only a list of the unique words, but also the number of times that they occur. So that's going to take a slightly different approach. And then the third thing is mimicking how a very, very simple search engine works. If I've got a number of files, I want to load in all of the files and store information about particular words, or well, all of the words, and the files in which they are found. So for example, I might find the same word in several files. If I then do a search on that word, it should tell me the files in which that word occurs. Something similar to if you think of how a simple internet search works. If you put in a word, then it gives you a list of websites which contain that word. I know that it doesn't, and there's a bit more to it, but it's a very simple kind of modelling of that process. Okay, so first thing, list of unique words. So what collection might we use here? Well, in the title it says list, but a list doesn't have unique entries. A list we can have repeated entries, but they're in sequence. We're not really bothered about the sequence here, but the fact that things are unique tends to suggest that we want to use a set. And but the other thing it said is if we want the words in alphabetical order, which would be useful if we're trying to look for a particular word, then a tree set would be useful if the words were stored as strings, because then they'll be just put into the set in the natural order, which is alphabetical. Okay, so let's have a look at the files that we're going to use. So here's the file that I'm going to use. This is Rudyard Kipling's If. If you can keep your head when all about you are losing theirs and blaming it on you, if you can gain yourself one of them, when all men doubt you but make allowance for their doubting too, if you can wait, not be tied by waiting, or be lied about, don't delete dealing lies, etc., etc. And what's more, you'll be a man, my son, at the end. That's a famous poem. It has the word if in it several times. It has the word you in it several times, and can and the. So it's going to be good for our analysis reasons. So if I have a look at NetBeans, I've already written the programs. Here's the first one. It uses a JFile chooser to open up a file called file, creates a scanner for that file, and then while there is a word to read, it reads in the word, converts it to lowercase, and then adds it to the word set. So any duplicates won't be added because they're already in the set. And then once it's been done, it prints out all of the words in the set very lazily. Just prints out the whole set, and then it iterates through the set one word at a time and prints out each word and a little counter next to it as well, so we can see how many different words we've got. I use a tree set at the beginning of type string, but the tree set, so that means that the words will be added in their natural ordering. Let's see if I run this, then I should get a file chooser. There it is. I put my file in the desktop. If I open it, it runs, and we'll see that go to the very top. The set is A, about, after, again, aim. So it's put all the words into the set. We should find the word if in there at some stage. There's the word if. It's the 54th in the sequence of words that we've got in order, but it doesn't really matter. It's only recorded once. Okay, so that's using a set. good for dealing with unique things. If we want to put things in order, we can use a tree set. I'll just go back to the second thing. So the second application we want to look for is a frequency analysis. So what collection might be useful here? Well, if it's a frequency analysis, then any duplicate words, we want to somehow store them. So a set isn't very as useful as perhaps it was, because a set would only add one occurrence of each word. So that's something that we can't use. But there is something called collections.frequency. So if we can get all of the words into a collection and use collections.frequency, then we can perhaps count how many of a particular word we have in a collection. So we need a collection which allows duplicates. A list allows duplicate entries, and we'll just add to the list. So read through the file, add everything into a list, an array list or linked list, doesn't matter. And if we can then, from the list, get a set of all the words, so get a set of the unique entries, then we can use that set to iterate through it and determine the frequency of each word. Okay, makes more sense if we actually just have a look at how I've solved it. So this is text analysis 2. So it's very similar to the last one, except that I've got a words list, which is just a list. I read through the file and add everything to words list, so duplicates will be added. But then what we do is I create a collection of unique words from the list. So I've got words set, not words list. And to do that, all I need to do is take the list and use add all. So add all will add all the words from the list into the set, but any duplicates wouldn't be counted. And then I can iterate through the set, which I know are unique words. And for every word in the set, I'm going to use collections.frequency to find the number of times the string S occurs within words list, and then print it out. Okay, so let's give that a go. So if I run this one now, hopefully it works. If I get my file chooser up, it doesn't like it. Let's see if I can just put a space in or something and get it to. Oh, it's still running in the background. Yes. Yes. Where's my file chooser? Doesn't like it, does it? Oh, here's my file chooser. I'm not sure. I must have made a mistake in one of my files back there. Oh, I didn't. I didn't. I don't think I've closed the scanner. But anyway, if I go to document, oops, not documents. It's what happens when things don't work properly. If I choose if again and open it, then this time it's ran the old file. Brilliant. Exactly what I didn't want. Exactly what I didn't want to happen. Right, let's try and run the file that I want. Desktop if. Right, that's better. If I have a look now, it's read in the list, and if we have a look for if, then if occurs 13 times, and you can have a look at the code and see why that is. Okay, final thing, the text index. So text index. So here we want to generate a list of words which are in lots of different files, but we want to associate each word with a file or file. So what collection is the most suitable thing here? But well, in this case, we don't want just a list of things. We want to relate a file and a word together. So we need to have something connect two things together, and a map is probably the best thing here. It's not the only way we could do it, but it probably is the best. A map could allow a unique word to be associated with a file or files. So the key would be a word, and the value would be a file or files in the, depending on how many we've loaded. How to store the list of files? Well, use a set probably, because once something's been added, then it doesn't get added again. So the best thing, I suppose, is if we use a tree map, then things will be ordered by the string, by the words, in the natural ordering. And so here, the strings are going to be words, and the set of strings is going to be a set of file names. Okay, let's have a look at that solution. I'm just going to make sure that everything's dead. Yeah. So text analysis 3. So here I've got a map of strings and a map with strings as values and a set of strings as, strings as keys, set of strings as the values, tree map. And what I'm going to do now is I'm going to not read in from one file, I'm going to read in from several files. And when we read in, if the text map contains the key already, so a word is already there, then I'm going to add to the set file name. So if it's already there, I add to the file name. Otherwise, I just add the file to, I create a new set, add the file name to the new set, and then put it into the map. So if there's already a set there, I have to add to the set so that the number of file names gets built up. Otherwise, I do this. And you can have a think about how that works. And then what I'm going to search for is the word Spock, the word the, and the word force. Okay, and to test that, I'm not going to use if, but I'm going to use Star Trek. There's some quotes from Star Trek. Everybody remember Where We Parked, from the one where they're looking for the whale. Star Wars. The Force is strong with this one, stuff like that. Star Wars 1. When I left, I was but the learner. Now I am the master. Yeah. These aren't the droids you're looking for, etc., etc. And Sheldon. So Sheldon talks about Spock as well when he does his paper, scissors, rock, Spock lizard game. Okay. So let's give this a go and run this. And hopefully I should get a JFile chooser. There it is. In desktop, I'm going to choose Sheldon and open that. I want another file. I'm going to choose Star Wars 1 and open that. Another file, Star Wars 2, and open that. Another file, what was it? Trek.txt and open that. No. And then, so this is the map now has the word 12 must appear in Star Wars 2 only. A appears in Star Wars 1, Sheldon, Star Wars 2, and so the word A appears in all 4 of the files. About appears in, I can't remember. Well, accurate appears only in Star Wars 2. Admiral only appears in Trek, etc., etc. So I've got a mapping of words to files, and if I search for Spock, then all I need to do is return the set of things corresponding to Spock. That's Sheldon and Trek, which is what I expect. He talks about the rock, scissors, stone, and Spock appears in the Trek quotes. If I search for the, it appears in all of them, and if I search for force, then it appears in the 2 Star Wars files. Okay, hopefully that's useful. Just more examples of using collections. Good luck.